Today we are going to see N-Queens problem. So there are n number of queens and n number of columns and n number of rows. So we have to place these queens in such a way that no two queens are present in the row or in the same column or diagonally present. Okay, for our convenience, let us take this n as 4. So there are 4 queens present, Q1, Q2, Q3 and Q4. So these 4 queens are to be placed in 4 columns and 4 rows. So this is 4 by 4 matrix, and the conditions are, that is, we have a constraint. So this problem has to satisfy this constraint. These constraints are no two queens are to be present in the same row or in the same column or diagonally present. So if 2 queens are present in the same row, it is a false condition. If 2 queens are present in the same column, it is not acceptable. And if 2 queens are present in the same diagonal, then this is also a condition where we cannot satisfy. So this constraint satisfaction problem is being given. So we are going to solve this using a technique which is called as the backtracking. For solving this using backtracking, we need to construct a state space tree. So state space tree, if you want to know more about it, you can refer to the previous video. And let us start by construction of this state space tree with respect to 4 queens problem for this backtracking method. We are not going to find all the solution, that is, it's not going to be an exhaustive search. It is only going to be a search whether it is a feasible solution, that is, whether it is going to be a promising node or not. If it is going to give a feasible solution, a correct solution, then we go about by selection. Otherwise, we ignore that particular node and we backtrack to the previous node and we try to find out the solution. So as we all know, initially to start with, it is a null condition where we don't have any solution or any placement of any nodes. So here there are possibilities of placing my first queen in 4 different locations. It can be either 1, 2 or 3 or 4. So when it comes to this location, my x value can be 1 or 2 or 3 or 4. So now let me first look into, if I place my queen in the very first location, what would be the other consequences? So the other 3 possibilities are, I cannot place the next queen, Q2, in the same column or in the same row. So the other options are going to be placing my queen on these locations. So it can be either on the node 2 or 3 or 4. So now let me tell you, so there are conditions which are to be satisfied. This is with respect to Q1 and this level is with respect to Q2. So now if I place my queen on the second box, what will happen? This condition will not get satisfied because they are going to be diagonal. So I need not consider this particular route. So now not considering that, I get back to this node again and I look into a solution based on the 3rd position. So if I place my queen in this, what does it satisfy? No queen is present in the same column or row, or diagonally it is not present. So I can continue with. So the placement of the next queen, that is Q3 queen, where does it go? It has to be in 2 places. It can either be here or here, that is node 2, or it can be in node 4. So if it is going to be in node 2 or 4, both the nodes are diagonally present. So there is no possibility of me placing these two queens in these two locations. So what do? I backtrack again and get back to the next node. So here all these are failure conditions where I'm not going to get the promising node. So now placing my queen on the fourth node. So here there might be a possibility. So what are the other nodes which are available? No queen can be present here. No queen can be present here. So the only option here we have, it can be either present in node 2 or 3. So considering this particular node 2, what do? So I have the queen placed here, here and here. So what do? The only option here is this. So if it is going to be the third node, what happens? It is going to be diagonally present. So now I cannot do that. So I get back and look into this node. So here these two are diagonally present. That is fourth node and third node are diagonally present. So I get back to this particular place as a backtracking method. So all my conclusion at this level is I do not get a solution if I place my Q1 in the first degree node. Okay, so what do I do now is I have to move this to the next position. So what is the next position? Is I have to go to this next box. In the second column, I place my first queen. So now I cannot place in this or this. So I have three options for placing my Q2. They are going to be 1, 3 or 4. So first one I take. They are diagonally present. So I cannot consider this. So I place here. They are also diagonally present. So I cannot go with this. So this would be a comfortable position for placing my queen so that they don't fall in the same row or column or diagonally present. So further expanding this, I cannot do this, this or this column or this row and everything. I have two options here. That is, I can either go for 1 or 3. Okay, now if I place my queen, the third queen on the first column, then what happens? I don't have any intersection or like I don't have any crossovers here. So I'll just see whether my next queen, where can I place the next queen? It is going to be here on the third. So I think all my queens are comfortably present. They are not found in the same row or same column, and there is no diagonal meeting. So all my conditions are satisfied here. Now supposing if I have my solution here, placing my third queen in the third column, what happens? They are diagonally present. So this node cannot be a promising node. So now expanding further makes no sense. So I get back and go to the next node. Now replacing the third, the first queen on the third column, I have 3 existence. That is, I can place it in the first, second or fourth. So if I place here, no problem, I can go about with. And what are the remaining 2 solutions which I have? I can either place it in 2 or 4. So if I place my next queen in the second, it is not going to be good because they are diagonally present. If it is present in the fourth, it has no problem. So the remaining is going to be 2. So 2, this one, if I place my first queen on the third column, second queen on the first column, and the third queen on the fourth column, and the fourth queen on the second column, it is not going to have any problem as no 2 queens are present in the same column or in the row, or they are diagonally present. So here this is also a solution which I have. Then getting back to this particular node, now I have to place this first queen in the third column, the second queen in the second column. So this is not a promising node because they are diagonally present. So now first queen in the third column and second queen in the fourth column, they are diagonally intersect. So now the next option would be placing the first queen on the fourth column. So I have 1, 2, 3 as the other options. So if I place the next queen here in the first column, they are not diagonally present, but I have 2 options here. I can place them in 2 or 3. So if I place 2, they are diagonal, it is going to be diagonal. If it is going to be 3, it is okay. So if it is going to be 3, my next node should be 2, which is going to be diagonal. So that is not a good solution. So I have to backtrack and get to this particular place. First one in the fourth location, second one in the second location, no problem. Then the third one, I either place it in 1 or 3. Both are going to be diagonally affected, so they are not going to be good solution. So the next one is placing the fourth one, the first queen, and second queen is being placed in the third location. They are diagonally present, so this is also not going to give me a solution. So all I find is I have got 2 sets of solution, that is 2, 4, 1, 3. This root gives me a solution, that is a feasible solution. Also 3, 1, 4, 2. This also gives a complete solution where I can get the correct answer. Let's quickly place our queens here in the second position, the next queen in the fourth position, then the third queen in the first position, and the fourth queen in the third position. So about this answer, placing the first queen in the third position, placing the second queen in the first position, placing the third queen in the fourth position, and placing the fourth queen in the second position. So both the cases we don't have any problem, that is all the conditions are being satisfied. No 2 queens are present in the same row, no 2 queens are present in the same column, or no 2 queens are present diagonally. So this is how we solve this n queens or 4 queens problem using the method backtracking by constructing a state space tree, and for each level, if the constraint is not satisfied, then we backtrack, go to the previous level and check whether the condition is being satisfied or not, and thus we get 2 different solutions. We have got as this as one solution, and the next solution was this. These are the two solutions satisfying these constraints for 4 queens problem. Hope you have understood the 4 queens problem. You understood how to construct the state space tree. Happy learning.